Hey, it's Michael Webb. I'm part of Looking Good Incorporated, and I'm going to be introducing the planning phase for our body size scanner system. The planning phase is really about why the project should be built and what the process is going to be to build it. It's two major steps. There's project initiation, and that includes the system request, the business reason, kind of what the value is going to be coming from the project. And then it also includes a feasibility analysis. That's economic feasibility, organizational feasibility, like are the people going to use it? Technical feasibility, like is it possible, from a technical standpoint? Um, the second major part of planning is project management. So you have a project manager that's in charge of staffing, developing a work plan. The deliverable is the project plan, which really discusses kind of how we plan on building a system. The systems analysts themselves have to have a whole myriad of different skills to be able to function well on the team. They need technical skills. Um, they need to be able to kind of understand the current technology at the company they're on, where they're doing the project, and kind of how that's going to relate to the proposed project, the 2B system technology. They need, you have business analysts in particular that really just focus on the business value and are able to kind of go over every detail and make sure that it makes business sense, economic sense. Um, Communication skills are a huge thing because they need to be able to present presentations, large and small groups, and to different groups, so senior level management and technical roles. And so you want to make sure that everybody can understand. You present information in a way that everybody can understand and take in. Another piece of that communication part is being able to kind of intervene and diffuse conflicts, or keep the project from kind of derailing over things like that. The first big part of planning is going to be the system request form. In our case, our sponsor is Mitchell Gabbers. So for our project, what we came up with is a given size from one brand to another is not physically the same. And our company receives many returns due to customers buying the incorrect size. By utilizing body scanning technology, our customers can get the correct size every time. This integrated clothing size scanner will drive customer retention, bring new customers, and reduce the number of returns, which will increase profits, reduce return fees, and place ourselves at the forefront of our industry. So in the system request, you kind of go over the feasibility portion. There's benefits, there's tangible and intangible benefits, and we would be projecting $68,901 in increased sales, new and existing customers, and $60,495 reduced in return fees. As far as intangible benefits, we're looking at improved customer experience, increased competitiveness, and expanding our customer base. Um, the economic feasibility really can make or break a project before it even starts, which is why the business analyst is a really important job there. The economic feasibility attempts to break down all the projected expenses and benefits, tangible and intangible. So you want to try to be as detailed and conservative as possible in this planning phase so that you have the clearest idea, clearest picture, and the steering committee that approves the project will have be more informed. And so in our case, you've got major costs are labor for analysis and design and implementation, upgrading the network and software. Then there's ongoing development costs like website maintenance, cloud server, advertising, network updates, and maintenance. Our initial projection is a 14.7% return on investment and a 3.32-year break-even point. For the methodology, we picked throwaway prototyping specifically because it's cost effective and it allows the developers that are unfamiliar with webcam technology integration to kind of learn in pieces, just because by itself it breaks down the project into modules. So it's going to help the developers understand the purposes of each feature via mock-up prototypes and address any concerns with developers and users along the way rather than at the end. Since it breaks it down into modules, it helps catch errors and bugs. It also saves money just from giving those developers the chance to kind of understand and learn the software at a pace rather than having to bring in specialized technical people. The big part, the second part of planning is the business, the project management, and the Gantt chart is a big graphical way for the project manager to organize a work plan. So it helps break down tasks by priority and includes the expected duration and due date, how far along each task is, and who is assigned each one. And that kind of concludes planning.
Now that the planning phase of the project is over, we can move on to the analysis phase and cover the strategies and techniques used to build the system requirements, use cases, activity diagram, and class diagram. For the strategies and techniques that we used in our analysis phase, for strategies, we have informal benchmarking, outcome analysis, and technology analysis. Informal benchmarking is used to learn about similar systems and how other businesses use them and how we can best have a competitive advantage or edge, and also how to better use our system itself. We used outcome analysis because our main outcome is calculating the correct clothing size for users. So we wanted to best figure out how to do that and make sure that was our main focus. And while we're figuring that out, we wanted to also figure out future updates and features that we could add after our main system is complete. Then we use technology analysis to help us fully understand what hardware and software both the users would need and the company would need to make sure that our system was fully functioning. For our techniques in the analysis phase, we used questionnaires, EJAD, and interviews. We used questionnaires to get opinions from our users and understand what they would think about the idea of a scanner before we implemented it, and also to figure out what kind of requirements they would want the system to have if they were going to use it. We will use EJAD to understand the viability of the project from managerial positions and how viable they think the project is. And it can also be used to clear future roadblocks between team members who might not see eye to eye on something, and we'll get it out of the way now during this phase instead of when it's either in production or being implemented. And this can also help us further understand the expectations from users. We used interviews to interview the previous developers of our packaged software, so we had a full understanding of how the software was originally made so that our team could better understand it when adapting it to work for our system. For the next part of the analysis phase, we have the requirements definition, which includes functional requirements like our permissions, calculating dimensions and clothing size, and then saving that as a cookie, as well as non-functional requirements including some operational requirements, performance requirements, security requirements, and some cultural and political requirements for our system. The first part of our functional requirements are webcam permissions. We will require explicit permission every time our site will be able to use a user's webcam. We also have calculating dimensions and clothing size, which will be once the webcam begins scanning, we have to calculate the dimensions, and then from those dimensions calculate the clothing size for the user across the entire site. And then also saving that clothing size as a cookie so that they do not have to scan they don't have to scan every single time they want to shop on the website. For the non-functional requirements for our system, the operational requirements, some of them are it has to be compatible with mobile devices and personal computers, desktops. Also, the system has to integrate with our already existing website and already existing systems. For performance requirements, we want the scanning to take less than 20 seconds, and then the calculating of those dimensions into a clothing size to take less than 10 seconds. We also want the system to have at least a 95% availability once we launch it. For our security requirements, like I said before, we want explicit consent every single time the webcam is accessed. Also, no user data collected by any of this system should be stored outside of the one cookie, which will also be given permission from the user to use. And also the webcam can only be accessed between when the permissions are given and once the cookie is saved, then it cannot be accessed outside of that. Also for the cultural and political requirements, we obviously will have to have privacy compliance with all privacy regulations at a local, state, and federal level. This is just one of our use cases, and it covers how somebody's dimensions after they're scanned should be turned into a clothing size. The other use cases are within our documentation. This is one of our activity diagrams. This one specifically covers the webcam and end user license agreement permissions, and it shows how if a new user will have to go through and accept the end user license agreement, but a returning user will only have to give permission for the webcam to be used if they've already gone through the process once. This class diagram covers our full functionality for our system. The first two classes you see were covered in the activity diagram from last slide, and how it grants permissions, and then the clothing size class was shown in the use cases from the slide before that.
The next step of developing this project is the design phase. Our design strategy that we chose happens to be using a package system. The reason we chose this instead of custom development is that custom development is kind of hard due to lack of team experience, and in fact our project has a non-flexible time frame. We also chose not to do outsourcing due to potentially sharing customer information, which is against our non-functional principles. The benefits of having a package system is that it's not overly complex to implement. It also has really good data protection for customers since it's only us who's going to be handling it. Our team has more experience in implementation of software such as this, and it's also more effective and cheap in the long run. It will require consultation with vendors to implement properly, however. We got to make sure it works well with the website and the people we're working with, and we may also need to hire a consulting firm to help with the integration of the software. For our method specifications, every single method we have has a specification, and you can find more details of this within our documentation. For our database design, we ended up deciding that all the classes will be used again to design the relational database. In this database, tables represent two different classes from the class diagram. We have the body part table, which will be used to get the clothing size and general information when querying the table. And the other table is the dimensions class, which will compare dimensions of the user to get the clothing size. The foreign key we're using is the BP side ID, and the tables are in a one-to-one relationship, so the columns will be the primary keys for the two tables. The clothing sizes will be stored as a cookie on the user's computer, and due to all this, this would mean some classes do not need tables for the database, such as the EULA agreement. For our user interface mockups, we decided to use the Get Webcam Permissions class, the Scan Dimensions class, the Obtain EULA class, and the Get Body Parts class. Background processes such as the Save Clothing Size cookie and the Calculate Clothing Size do not need any UI, so they're not included here. Looking at the UI, you can see that you can select the body part you would like to scan, or you can cancel, or you can begin once you select. We also have our license agreement right there at the bottom and goes over the details of everything that the user might need to know on a legal scale. Our physical architecture is going to be involving a client-server architecture, and this is because it is overall having a lower cost, and the client's devices being able to handle most presentation and application logic. It also supports better interface capabilities and has GUI support. It's also scalable, so as the business grows, adding more servers or other growing features is easy. And our physical architecture is going to be used on a 4-tier architecture. The first tier is a client web browser, which is used for presentation logic. The second tier is the web server, which already exists on the website and is for web-related application logic. The main application server is to perform the main functions of the system, such as the code to calculate clothing sizes. And the last one is the database server, which will be small and hold only the very little information needed. Application server and the database server need to work in the existing architecture and will use the Windows OS. It will run C++ code, and the database will use Transact SQL. Our server hardware we came to decide will be using 768 GB memory, 1 TB disk drive, Intel Xeon E-2174G processor, 10 gigabytes per second network speed, and of course a monitor. Application server and database will be cloud-based and will implement IBM Cloud. We chose this because it's scalable, so the company can request more memory and storage as we need it. It's cost-effective since we only are going to pay for what is needed, and it's environmental friendly by not producing waste via recycling through equipment.
With the design phase now completed, we move on to the last and final step, the implementation phase. For the project's documentation, we decided to go more along the lines of using tutorial type documentation. The basic structure would be first the agreement, so the EULA, the agreement between the company and the user, and this also would include the webcam usage agreement. In the next major part, we would describe the terms and definitions and commands. So the user would probably want to know what each part of the body might entail. So we would probably define torso to include the chest, stomach, and probably arms regions. And we also include some how-to. So how to agree to the agreements, then how to use the basic system. Click on this button, select the body parts, have your body parts in view of the camera. That would be like the general format of our tutorials, and these tutorials will describe the basic usage of the system and some general specific cases. For the systems test plan, we have 4 main parts in this. For the unit testing, we decided to do a black box style testing. This will help to ensure that all the requirements decided at the first steps of the project are met and fulfilled. Secondly, for the integration testing, we decided to do an interface testing. This will make sure that all the UIs the system has works and is easy to understand. Thirdly, for the systems testings, there are 3 main parts. Security, which will help make sure the webcam cannot be hacked into. The performance testing, which will help make sure that thousands of users can handle it at the same time. And requirements, just to make sure the system works and nothing breaks it. Lastly, for the acceptance testing, we decided to do beta testing just so some select users can test the system out before the whole thing is introduced. For the systems conversion strategy, we will use a direct phased whole system style conversion. The direct and whole system parts kind of go together. Since our system cannot be broken down into pieces and is more of an add-on to the existing systems, it makes sense to add it in all at once and just do it cold turkey. For the phased part, we decided that certain regions might get access to it before, and this will just compile on till all the regions have access to it. To convince the users to actually engage in the system, we will have our sponsor release some promotional videos. We will also set up some basic tutorial videos that help the user see how to use it and why it is helpful. And there will just be some small pop-ups that are not annoying that just explain why this system can help the user ignore some return fees and stuff like that. Additionally, we will also have to train the in-house staff some, just so they don't know how to use it and how to help users if they call in experiencing problems. Once the system is fully implemented, we will now have to conduct some post-implementation activities. For the maintenance, we will do the freeze-on-freeze method. Whenever there is an update to be made, we will temporarily suspend the system, so freeze it, and make the update, so probably take this about an hour. Then we will unfreeze the system, and this will give the users the update and the system to use again. We will also include a changelog and any updates to any tutorials that are needed. As part of this post-implementation activity, we'll also conduct a system review. Overall, it went pretty smoothly. Our programmers, while they didn't know how to work with webcam technology at the beginning, they got some good experience and they will be able to work with more webcam technology in the future. There were some few bumps in the roads, but overall, the system got built in a very smooth manner. The final part of the project assessment is the actual project and review of this class's team. So some lessons that our group learned is that we probably should have had more talking sessions. We had one talking session throughout the semester, and we just mostly communicated in the text chat and Discord. We should have done more talking because this would help better our communication and made some of the requirements more clear. Another thing we noted is that we probably could have done a little bit better research into some of the costs of some of the things. However, a lot of our project went well. We had very few arguments and roadblocks and what to do and how to do it. And a big benefit of our team is that everyone did their part. Ryan Porter did a lot of the leading. Kelvin Courtney and Michael Webb did a lot of the editing and a lot of the steps, and Thomas Moon did a lot of the graphics for the charts and figures and stuff like that. So overall, our team was pretty well, but we should have had better communication, and that would have helped the project a lot.